Hello, today we're going to be looking at the last lesson of Chapter 10, 10.8, working with equations of circles. So today's lesson is going to center around the top of your note sheet, which shows you the equation for a circle in standard form. Notice the equation says x minus h squared plus y minus k squared equals r squared. H and K represent the coordinates of the center of the circle, and R is, of course, the radius of the circle, its length. In the formula, the radius always gets squared. If you take a look at the picture at the top here, it's showing you the center of the circle, H, comma, K, X and Y coordinates, the radius of length R, and then another random point on the circle. We know that circles are made of infinitely many points, so when we write the equation for a specific circle, we only fill in h and k, the center, and the radius r. We do not fill anything in for x and y because they represent the many points that create the actual circle. In the first few examples, we're looking at working with an equation of a circle and using it to find the center, radius, and graph. So if you take a look at this formula, remember it's x minus the x coordinate of the center, y minus the y coordinate of the center. So we can pull the center of the circle directly from the equation. We have to change the sign of each of the values because the formula is minus. So the x coordinate is going to be -5, and the y coordinate, since it's already -2, will be a +2. The right side of the equation represents the radius squared, so the radius, if the radius squared is 9, should be just 3. We square root that 9. To graph a circle, you should always start by plotting the center. So if I plot the center of this circle at -5, 2, should be here. And then we know that all radii are the same length. So if we go 3 units away from the center, we can find the outside of the circle. So I'm going to go up 1, 2, 3 units. To the right, 1, 2, 3 units. Down, 1, 2, 3 units. And left, 1, 2, 3 units. Once I go 3 units in each direction, I'm going to connect the dots, create a circle, do the best that you can. Obviously, mine is not perfect. But you'll be graded on the points and not the accuracy of connecting them. Okay, the second equation is in standard form as well, so we can simply pull out the center by looking at what's added or subtracted to x and y. So we have x minus 3, so the x coordinate of the center is 3. Y doesn't have anything added or subtracted, so the y coordinate of the center is 0. Plus or minus 0. On the right side of the equation, r squared is 16. So if we square root 16, the radius should be 4 units. Again, to make the graph, we start by plotting the center. This time we're at 3, 0. And then we're going to use our radius to move 4 units in each direction. And connect those points to create the outside of the circle. In the next set of examples, instead of being given the equation of the circle, it's going to be our job to write the equation of the circle. When you write the equation for any circle, there are 2 things that you need to know: the center and the radius. In the first example, it gives us both of those things. The center is located at the origin, which we all know is at 0, 0. Radius is 3. If we plug that information into our formula, it says x minus the x coordinate of the center, which is 0, squared, plus y minus the y coordinate of the center, which is also 0, squared, equals the radius squared. So our radius was 3, and that gets squared. Let's clean up the equation a little bit x minus 0 is just x, which still gets squared. Y minus 0 is y, which gets squared. And 3 squared is 9. Here's the equation of the circle with its center at the radius, at the origin, and a radius of 3 units. Number 4 is similar, but notice that instead of giving us the radius, we're given diameter. Of course, we all know that the diameter is twice the length of the radius. So if the diameter is 4, the radius is half of that, or 2 units. Again, we can plug our center into our formula. The x-coordinate is represented by the letter H, y-coordinate, the letter K. So if we put this information into the formula for the circle, we do x minus h, so minus negative 2 squared, plus y minus the k value, 4 squared, equals our radius squared, so 2 squared. Again, clean up the equation a little bit, so minus negative becomes plus, so we have x plus 2 squared, plus y minus 4 squared, equals, on the right side of the equation, 2 squared is 4. In the next question, we're still going to write the equation of the circle. We're given the center, h and k, and this time instead of getting the length of the radius, we know one of the radii has an end point at 0, 6. So if you imagine, I'm going to make a rough sketch, very rough sketch, of this circle. If the center's at negative 3, 6, and one end of the circle is at 0, 6, we can imagine that the circle looks something like this. Remember, we need to know the center and the length of the radius in order to write the equation. So if I use the center point given and one endpoint of the radius, I can find its length. So I'm going to start by doing the distance formula to figure out the length of the radius. So if I plug these two things into the distance formula, let's do 0 plus 3 squared and 6 minus 6 squared. That would be 3 squared, which is 9, and 0 squared, which is just 0. 9 plus 0 is 0, and when we take, or is 9, excuse me, and when we take the square root, we find out that the radius is 3 units long. Now that we have both the center and the radius, we can write the equation of our circle. So our circle is going to be at x minus the x-coordinate of the center, negative 3, squared, plus y minus the y-coordinate, which is 6, squared, equals our radius squared, so 3 squared. Again, clean up, so this will become y plus 3 squared, and y minus 6 squared equals 9. If you flip your paper over to the back, there's another example asking us to write the equation of a circle. But this time we're not given either the radius or the center of the circle. All we know is that the diameter of the circle has endpoints at 2, 7 and negative 6, 15. Remember that the diameter is a chord, runs through the circle but starts and stops on the circle, and it has to run through the center of the circle. So we can use the diameter to find both the center of the circle and the length of the radius. So the center, of course, is smack dab in the center, meaning that it's going to be the midpoint, exactly in the middle, of these two coordinates. So to find the center, we're going to calculate the midpoint of these 2 points. So we'll average the x-coordinates, 2 and negative 6 divided by 2, average the y-coordinates, 7 and 15, divided by 2. 2 minus 6 is negative 4 over 2. 7 and 15 is 22 over 2. And when we simplify, this becomes negative 2, 11. To find the length of the radius, we can do one of two things. We can either use the original 2 coordinates to find the length of the diameter and then cut it in half, or we can use the center and one of the points to find the length of the radius. So I'm going to go with the latter option. I'm going to use the center point and this coordinate on the circle, 2, 7, and calculate the length of the radius using the distance formula. So here we have 2 plus 2 squared and 7 minus 11 squared. 2 plus 2 is 4, squared is 16. 7 minus 11 is negative 4, squared is 16. 16 and 16 is 32. For this question, I'm going to leave the radius as the square root of 32. I'm not going to simplify the radical. I'm not going to find the decimal. And the reason for that, you'll see in just a second. So now that we have our center and we have our radius, we can write the equation for this circle. So let's do x minus the x coordinate of the center, negative 2, squared, and y minus the y coordinate of the center, 11 squared, equals our radius squared. So the square root of 32 squared. The left side of the equation cleans up to x plus 2 squared plus y minus 11 squared. And on the right side, the reason I did not simplify the radical is because the square root of 32 squared is simply 32. We will always write the equation of a circle in standard form, but circles aren't always given in standard form. So in order to take a circle in any form and change it into standard form, you have to use the method of completing the square. At this point, if you're not familiar with completing the square, or you need a refresher, you should pause the video, watch the video about completing the square, and then come back to finish the last 2 questions. If you do remember completing the square, you can continue from here. So it says, when necessary, use completing the square to write the equation of the circle in standard form. To complete the square on a quadratic of the form x squared plus bx, remember that we find half of b and then square it. That number gets added to our quadratic to make a perfect square trinomial. Whenever you add something to one side of an equation, to keep it balanced, you have to add that same value to the other side of the equation. So whatever we add for half of b squared to one side, we'll also add to the other. Particularly for writing the equation of a circle, remember we need x minus the x coordinate of the center squared and y minus the y coordinate of the center squared. So we're going to take the 2 terms that have x's in them, use that to complete the square, make a perfect square trinomial. Then we're going to take the 2 terms with y's, complete the square again to make another perfect square trinomial, so that we can then factor each part and turn our equation of the circle into standard form. So if we look at just the x's for now, the value of b, what's attached to the plain old x, is negative 6. So to complete the square, we always do half of b, and then we square that number. So half of negative 6 is negative 3. Negative 3 squared is 9. That's the number we add in order to make a perfect square trinomial, to complete the square. So for the x's, this is going to become x squared minus 6x plus 9. But remember, whatever we add to one side of the equation, we have to add to the other in order to balance it out. So on the right side of the equation, I'm going to add a plus 9. Okay, now we're going to complete the square with the y's. The b value for the y's, or the number attached to y, is 4. So in order to complete the square, we take half of 4 and we square it. Half of 4 is 2. 2 squared is 4. So the b value for the y's is 4. That's the number we add to make it a perfect square trinomial. So now if I take the y portion of our equation, plus y squared plus 4y, we're now going to add 4 to complete the square, which means we have to add 4 to the right side of the equation to keep it balanced. The whole idea of completing the square is to turn each of these items into perfect square trinomials that can be factored. So if we now factor this first parenthesis, x squared minus 6x plus 9, if you think about the factors of 9 that add to negative 6, those two factors would be negative 3 and negative 3. Multiply to 9, add to negative 6. So this factors into x minus 3 and x minus 3, which is of course the same thing as x minus 3 squared. When we look at the y's and we factor again, the two numbers that multiply to 4 and add to 4 are 2 and 2. So this would factor into y plus 2 and y plus 2, which is the same as just doing y plus 2 squared. On the right side of the equation, we can combine like terms. So 3 plus 9 is 12, plus 4 is 16. And now we have the equation of the circle in standard form. X minus h squared plus y minus k squared equals r squared. Once the equation's in standard form, it's very easy to find the center and the radius. Remember, to get the center, we look at the coordinates or the numbers attached to x and y, but we always change their signs. So the center is located at positive 3, negative 2. The right side of the equation is always r squared. So if the radius squared is 16, then the radius must have length the square root of 16, or 4 units. Okay, for this last question, I didn't mention it before because it did not apply, but we're going to complete the square again in order to write the equation of this circle in standard form. But when you complete the square, if there's an extra constant on one side of the equation, you should move it over to the other side before you begin. You'll also want to group together your x terms and your y terms. So I'm going to rewrite this equation, and I'm going to write it as x squared plus 8x plus blank, because I know I'm going to complete the square and I'm going to have to figure out what to add. Then plus y squared minus 14y plus another blank, again to complete the square, equals, when I move 40 over to the other side, I'm going to subtract it and add the two numbers that I used to complete the square. To find those numbers, I'm going to focus first on the x terms. So 8 is b, the number attached to x. To complete the square, we find half of that number and square it. So half of 8 is 4, squared is 16. So I'm going to add 16 to the x terms and add it to the other side of the equation to keep the equation balanced. For the y terms, the b value, the number attached to y, is negative 14. Half of that is negative 7 squared is 49. So I add 49 to the y terms and the right side of the equation in order to keep it balanced. Now I factor the first trinomial and the second trinomial. So the factors of 16 that add to 8 are 4 and 4, which means that this trinomial factors into x plus 4 times x plus 4, or x plus 4 squared. For the y's, the factors of 49 that add to negative 14 are negative 7 and negative 7. So this factors into y minus 7 squared. And on the right side, I combine these like terms. So negative 40 plus 49 is 9, plus 16 is 25. Now we have our equation in standard form, so we can pick out the center and the radius. The center of this circle is located at negative 4, positive 7. The radius, if the right side of our equation is 25, square root of that would be 5 units long.